Today we're going to take a look at solving systems using the elimination method. Now, sometimes this is referred to as the addition-subtraction method. I like to think of it just as the elimination method because what you're trying to do is eliminate a variable. That's just exactly what it sounds like. And we could use addition or subtraction when using the elimination method. So here's our whole goal with this. We want to eliminate a variable by either adding the columns together or subtracting the columns together. And what we are looking for, so if I look at this first problem, what we're looking for is to get 0 on one of the variables. So if I look at this first system here, if I look at the x's, 6x and 2x, if I add 6x plus 2x, I get 8x. If I subtract 6x and 2x, I get 4x. So I'm not going to get 0 with the x values there, just how in the current state that they are in. But if I look at the y's, here I have a -1 and a +1. So since I have a -1 and a +1, I need to think about what would get me to 0. What operation should I perform to get me to 0y? Because if I get 0y, then that means I've gotten rid of the y's. So -1 plus 1 is 0. If I just add these columns together, I get 6x plus 2x is 8x. -1 plus 1 is 0. So that means I've eliminated the y's. Now, if you're not sure on that, look at this. If you have -1y and y, and you're like, I don't know if I should add or subtract. If you subtract, here's what's going to happen. You're going to have -1 minus 1, because this is a 1y. -1 minus 1 is -2. That does not get me 0y. So it doesn't eliminate. But if I add -1y plus 1y, -1 plus 1 is 0. I've eliminated the y's. That is the whole goal with elimination. And I couldn't do that with the x values in the current state that they were in, because 6 plus 2 is 8, 6 minus 2 is 4, not going to get 0. But I could work with these y's here. So that's my elimination. I've eliminated the y's. 6x plus 2x is 8x. 28 plus 12 is going to be 40. And then from here, I could just solve this one-step equation. Look at that, one step. X equals 5. So I have x equal to 5. Now I need to go ahead and figure out what y is. So I'm going to substitute x equal to 5 back into one of these equations, and I have the freedom to do either one. I usually prefer to just go with the easier looking one. That one looks pretty easy. So I'm going to substitute into the second equation. 2 times 5 plus y equals 12. So 2 times 5 is 10 plus y equal to 12. I'm going to subtract 10 from both sides. So I get y is equal to 2. So there is my ordered pair, 5, 2. And the hardest part about solving with elimination is just that first step. Just trying to figure out what operation should I perform, where should I be looking. I'm noticing that they have those coefficients of -1 and 1, so that's what I'm keying in on. I could eliminate that somehow since those are both a value of 1. I know one's a -1, one's a +1, but I could eliminate that somehow with addition or subtraction. So that's what I'm focusing on. So I had different signs there. If I have different signs, the operation we want to perform is addition. Opposite signs, different signs, whatever you want to think about. -1 and 1, add those together, you get 0. So number 2, I have -4x minus 6y equals 10, 3x minus 6y equals -18. So looking at the x's first, just go, if you're new to this, you just look at each column, see, is there any way I could get 0 here? -4 and 3, I cannot get 0, because -4 plus 3, -4 minus 3, not going to get 0. But if I look at the y's, -6 and -6, they are both negative. They're both negative. So in this case, since they have the same signs, they're both negative, and it could be both positives or both negatives. But in this case, I want to subtract, because if I have the same signs, like if I have 5 and 5, how do I get 0 if I have 5 and 5? I subtract. If I have -5 and -5, how do I get 0? I subtract, because -5 plus 5 is 0. -5 minus a -5 is really -5 plus 5. Minus a negative becomes a plus. So that is going to be 0. So if we have the same signs, we want to subtract. So I'm going to subtract. When I perform subtraction, let me rewrite this. -4x minus 6y equal to 10, and 3x minus 6y equals -8. When I perform the subtraction here, I like to encourage this. Put that in parentheses. So then that way you see that I'm doing -4 minus 3, -6 minus a -6, 10 minus a negative 18. So everything is being subtracted. And if you don't put the parentheses, that's completely fine. But it's just easy to just, drop the negative, or just see, like, or if you're looking at just this column and then doing 10 minus 18. Well, really, it's 10 minus a negative 18, which is going to be 10 plus 18. So here we go. Negative 4x minus 3x is negative 7x. Negative 4 minus 3 is negative 7. So negative 7x. Negative 6 minus a negative 6. Negative 6 minus a negative 6 is negative 6 plus 6, which is 0. So I've eliminated the y's. And then we have 10 minus negative 18. 10 minus negative 18 is positive 28. So I get equals 28. I'm going to divide by negative 7. X equals negative 4. This is the hard part right here, that first step. Now it's solving a one-step equation. Then it's substitution back into one of the equations to get the other value. Nothing super complicated from there. I'm going to erase all of this over here. Don't really need that on my screen. So now I'm going to take x equal to negative 4. And I have the freedom to substitute into either one. Both of them are not looking super great, but I'm going to go on the top there. Or sorry, not the top, the bottom. So I'll have 3 times negative 4 minus 6y equals negative 18. So just directly substituting into the second equation. 3 times negative 4 is negative 12 minus 6y equals negative 18. And then solving for y. So adding 12, negative 6y equals negative 18 plus 12 is negative 6. Divide by negative 6, y equals positive 1. So my ordered pair would be negative 4, 1. So we saw both scenarios that could play out. We see different signs, opposite signs, negative and a positive. So that's addition. Whoops, didn't mean to do that. That's addition, because we want to get 0. And then here we have same signs. They're both negatives. They're both negatives, a negative and a negative. So negative minus a negative is really negative plus the value. So that'd be just 0 there. Now we have to look at some potential problems with elimination, though. And not really a problem, but just a little bit of some extra work. So if I look at this next problem, x plus 3y equals 2, 2x plus 2y equals 0. And I'm trying to eliminate. I don't have an easy elimination with the x or y. Look at this, 1x and 2x. 1 plus 2, 1 minus 2, not going to 0. 3 and 2. 3 plus 2 is 5, 3 minus 2 is 1. I'm not eliminating the y's. So in this problem, I don't have an easy elimination right from the current form that it's in. Not a huge issue. I can create a scenario where I can eliminate. So what I want to look for next is a coefficient of 1. You see how this x has a coefficient of 1 right here? So x has a coefficient of 1. Since this is a coefficient of 1, it can be easily manipulated. I can make these x's the same by multiplying the top equation by 2. Because I want to make these both 2x. If this is already 2x and this is a 1, I can multiply it by 2. 2 times 1 is 2, so they're both 2x. So that's what I'm going to do. I'm going to multiply my top equation by 2 to make this 2 times 1x is 2x. 2 times 3 is 6y. 2 times 2 is 4. Now on the bottom, I'm not changing anything on the bottom. I'm leaving the bottom as is. Now I have 2x and 2x. Both positive, same sign. What do we say about same signs? Same signs are subtraction. So we want to subtract. So I'm going to subtract. I like to put parentheses around this so that way I have that visual of knowing I'm subtracting everything off. 2x minus 2x is 0. 6y minus 2y is 4y. 4 minus 0 is 4. So I'm going to divide by 4. Y equals 1. So there's my y value. Hard part's over. Now it's just solving. So 2x plus, I'm going to use the top one. Both of them aren't too complicated, but I'm going to have x plus 3 times 1 equal to 2. X plus 3 times 1 is 3 equal to 2. X equals, I'm going to subtract 3 from both sides. 2 minus 3. 2 minus 3 is negative 1. So we x equal to negative 1. So order pair, negative 1, 1. So that one we had to modify just one equation, and my key here was this. I looked for that coefficient of 1, to make it the same as the other x value. Let's move on. And this next one, 2x plus 3y equals 4, 6x plus 9y equals 0. So on this problem, same thing. I don't have an easy elimination, so I have to do some modifications. If you're somebody who can kind of work ahead a little bit, you might be noticing something right away. And maybe you don't, then that's fine. But here, I'm going to make the x's the same. And the way I'm going to make the x's the same is because I have a 2 and a 6. So I can just multiply the top by 3. 3 times 2 is 6. So then that would make the top equal to the bottom. So here we go. Let's do that. 3 times 2x is 6x. 3 times 3y is 9y. And 3 times 4 is 12. Then the bottom equation is not changing at all. Did not modify that at all. Interesting. 6x, 6x. 9y, 9y. I didn't intend for this to happen. What my goal was to make these x's the same. But the y's also became the same, though. Let's just keep going. All right, so now I have same signs, 6 and 6. So I'm going to subtract. 6x minus 6x is 0. 9y minus 9y, so this is 0. 9y minus 9y, 0. 12 minus 0 is 12. 0 plus 0 is 0. 0 equal to 12. So we see the 0 equal to 12. This is a false statement. 0 does not equal 12. So right now, since I got this false statement, I'm going to make the conclusion of no solution. We talked about this before. If you get the same statement, 12 equals 12 or 0 equals 0, then that's infinite solutions. But in this case, since the x and y's both dropped out and we get 0 equal to 12, then we'd have no solution. Number 5, let's see this one. So solve using elimination. 6x equals negative 11y plus 18. 3x plus 4 equals 9. So in this one, you got to make sure you're paying attention because we have 6x equals negative 11y plus 18. We got to get everything together. We have to have x and y on the same side. So I'm going to add this 11y over. So I'll have 6x plus 11y equals 18. And then 3x plus 4y equal to 9. Now I want to just solve. What I'm noticing is my x's. This is looking pretty good because 3 goes into 6, so I could just multiply the bottom by 2. That's going to be, I'm going to go over here, 6x plus 11y. I'm just rewriting the top equation. And then I'm multiplying everything on bottom by 2. 2 times 3 is 6x. 2 times 4 is 8y. 2 times 9 is 18. Now I've generated 6 and 6, same coefficients, so I'm going to subtract, put parentheses around that. 6 minus 6 is 0. 11 minus 8 is 3y. 18 minus 18 is 0. This is fine. Like, don't look at that 0 and think, uh-oh, I'm going to have a no solution or an infinite solutions because I have 0. That's not true. It's just 0 is any other number. It's just 0. It's the same thing as if it was 3y equals 1 or 3y equals 2. It's just 0. We still have a variable in play, so let's solve for that variable. I'm going to divide by 3. So that means I get 0 divided by 3, which is 0. Zeros are looking rough right now. So I get y is equal to 0. So that means I'm going to substitute in y back into one of the equations for 0. So I'm going to use, I like the top one actually because 6x, the x is already by itself because we're going to solve for x. So I'm just going to reuse that. I'm going to say 6x equals negative 11 times 0 plus 18. 6x equals negative 11 times 0 is 0. 0 plus 18 is 18. Divided by 6. 18 divided by 6 is 3. So the order pair I get is 3, 0. Looks scary. That one looks scary from the start. But once we just modified it a little bit, got things in the right place, saw that nice clean elimination right there, worked out pretty nicely. Let's take a look at this one. So we don't have an easy elimination. I'm going to make the something happen here. I'm going to work with the y's this time because see how I have this coefficient of 1y? I'm going to work with that. I'm going to make this a 4. And I can make it either a 4 or a negative 4. It doesn't matter. Because if I make it a 4, it'd be 4 and negative 4. So how do I get rid of a 4 and a negative 4? I add them together. 4 plus negative 4 is 0. Or if I make it a negative 4, I'll have negative 4 and negative 4. So that's subtraction. So I could do it either way. I like to work with addition. So I'm going to multiply just by a positive 4 to make these opposite. So I'll have 4 and negative 4. And that's just personal preference. So 4 times 3 is 12x. 4 times 1y is 4y. 4 times negative 4 is negative 16. Negative 12x minus 4y equals 16. And it's easy to kind of get distracted because now you see 12 and negative 12, you see 4 and negative 4, like, something's going to happen here. Don't get distracted. Just try to keep going through your process. If you made the y's the same or opposite or whatever you tried to do, work with that. Now you say, I have a 4 and a negative 4. How do I get rid of that? I add. Oops, didn't mean to do that. So since I'm adding, erase. There it goes. Since I'm adding, 12 plus negative 12 is 0x. 4 plus negative 4 is 0y, which is just 0. 0x is 0. 0y is 0. Negative 16 plus 16 is 0. So I get 0 equals 0 in this case. 0 equal to 0 is a true statement. Yeah, that is 0 does equal 0. So in this case, I have infinite solutions. Just like how we talked about with graphing, infinite solutions, 2 lines stacked on top of one another. We saw it again with substitution, now in elimination. Same thing could happen, just like how we had this no solution problem here where we have 2 parallel lines. But same things can happen. I think I got one more. Yeah, last one here. A little bit of a messy fraction problem. Not difficult, like overly difficult, but a little bit messy. So we have these fractions. Now for me, like I can't look at this and say, I'm going to start eliminating things by multiplying it by this or that. What I'm going to do is I'm going to wipe out the fractions. And the way we do that is we just multiply by the LCD. So in this case, on the top equation, so if I have x minus y over 11 equals negative 1, in order to wipe out the fraction, I'm going to multiply by the LCD of 11. So I'm going to multiply everything on top by 11. So 11 times x, 11 times negative y over 11, and then over here, 11 times negative 1. So 11 times x is 11x, minus 11 times negative y over 11 is just going to be minus y, because the 11's cancel. That was my whole goal. Because 11 times negative y over 11, 11's are going to cancel, so I'm just left with negative y, equals negative 1 times 11 is negative 11. On the second equation, I need to multiply by a 20 because that is a denominator of 20. 2 goes into 20, 4 goes into 20. So we know if we just multiply by 20, we will be completely fine and we will wipe out those fractions. So I'm going to multiply over here by 20, multiply over here by 20. So 20 times negative x over 2, that's going to be negative 10. 20 divided by 2 is 10, so negative 10x. Let me actually write it over here. Negative 10x. 20 times y over 20. That's just going to be y. So 20's cancel out, so plus y. That's plus, yep, plus. And then 20 times a fourth, so 20 divided by 4 is 5. And look how nicely that worked out for us. Because I have negative 1 and positive 1. Those are opposites. I can just add now. So I'm going to add these together. 11 plus negative 10 is 1x. Negative y plus 1y is 0. Negative 11 plus 5 is going to be negative 6. So x equals negative 6. Just like that. So x equals negative 6. Let's go ahead and substitute it back in. Hopefully this isn't too messy of a substitution here. So I'm going to take x equal to negative 6. I'm going to substitute back into the top one. I'm going to substitute back into here. So negative 6 minus y over 11 equals negative 1. Let's just start solving, and I think this is going to work out nicely, actually. So negative y over 11 equals negative 1 plus 6 is positive 5. I'm going to multiply by negative 11 to get rid of that division of 11. And I'm going to multiply by a negative because we have a negative y. So I'm multiplying by negative 11. So that's going to give us y equals negative 55. Worked out nicely. So our ordered pair would be negative 6, negative 55. Good problem. I know on face value, this problem with these fractions here, like that looks pretty scary, and yeah, rightfully so. Like that is not an easy navigation right away. But once you see it a couple times, like, okay, I'm just trying to wipe out fractions. Like, I'm just trying to get rid of those fractions, so I'll multiply by the LCD. So once you understand that concept of just trying to wipe out those fractions, just like how you would with like an equation, if you had like x over 7 minus 2 over 14 equals 15 over 14 or something like that, you try to just get rid of the fractions by multiplying by the LCD. Same concept, where we're just taking each one and then we create these fractions. So hopefully this was okay, especially with that last one.